So when we're talking about angles of a circle, we can go from 0 to 360 for one full circle, and let's go ahead and divide this up into smaller parts. Half of 360 is 180 degrees. Half of 90 degrees is 90 degrees. And just counting, 90 plus 90 is 180. 180 plus 90 is 270. And 270 plus 90 is back to 360. So one thing we want to realize is that we can always describe this circle into 4 easier parts. Instead of just looking at the circle as one big circle, we can talk about this as quadrants. And quadrants refers to 4, so we can break this into 4 different quadrants. And we're not going to call this northeast, northwest, southeast, southwest. We're going to call this quadrant 1, 2, 3, and 4. And it allows us to talk about these very quickly because each of these 4 quadrants has its own characteristics. Like if I pick any value or any point, in quadrant 1, aren't all the x and y's values positive in quadrant 1? See, all the x values and all the y values are both positive in quadrant 1. In quadrant 2, all the x values and y values, the x's are all negative. So we're negative, and all the y values are still positive. We're to the left because we're negative, but we're also still up, so we're positive. So these are some things we want to take note of. In quadrant 3, for x and y, all our x's are negative and our y's are also negative because we went left in the x direction and down in the y direction. And in quadrant 4, our x's and y's are all positive x and negative y. We have a positive x direction, but then a negative y direction. So some things we can take away right now is that there's some characteristics that are true for all these quadrants. To repeat that, in quadrant 1, all the x's and y's are going to be positive. This is the funnest place to be, quadrant 1. In quadrant 2, all the x's are negative, but the y's are still positive. In quadrant 3, all the x's are negative, but the y's are sadly also negative. They're both negative. And in quadrant 4, our x's are back to positive, but our y's are negative. Now, another thing to add about these quadrants is that these quadrants are not defined on the 90-degree angle. For instance, at 90 degrees here, 90 degrees is not in quadrant 1 or in quadrant 2. It is not defined on either of these. So if I'm standing straight up, if I'm on the border, imagine if you're standing on the border between Canada and the US. What are you? I don't know. You're on the border. Okay. So, but if you swing to one side, we'll be in quadrant 1. Swing to the other, we'll be in quadrant 2. But we can't say 90 degrees is in either quadrant. It's actually not in either quadrant. It's not in either quadrant. Okay. Now, let's talk about some other thing. In quadrant 1, so let me write this in angles. It goes between 0 degrees all the way up, all the way up to 90 degrees. Whoops. Yeah, we can do that. 90 degrees. Okay. In quadrant 1, we consume all the angles from 0 degrees all the way up to 90 degrees. So if we choose a simple example like 50 degrees is in quadrant 1. 78 degrees is in quadrant 1. 12 degrees is in quadrant 1. These are all in quadrant 1, so we automatically know, okay, angles less than 90. We're stuck in the right corner, upper right corner. Okay, moving on to quadrant 2. In quadrant 2, let me find some space. Between 90 and 180. Between 90 and 180 degrees. And you can tell, starting from 90 degrees over, all angles would fall in quadrant 2. So we want to get in our brains, okay, if it's less than 180, if it's less than half a circle, but yet greater than 90, a quarter of a circle, we are stuck in quadrant 3. We're going up and left. Quadrant 3 would be 180 degrees to 270. Just to help you guys out counting these are counting by nines. 9, 18, 27, 36. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So if I'm stuck, let's give you an angle 200. 200 is in quadrant 3. 250 would be in quadrant 3. And the last one is between 270 and 360. We are back into quadrants 4. So if I say angle 300, that is in quadrant 4. If I give you angle 288, that is in quadrant 4. So this is the start of the basics of idea placement. So if I ask you for any values in quadrant 1, you can tell me all those points that fall in quadrant 1 will always be a positive x and a positive y answer. And this is going to be helpful to us as we go into what we call sine and cosine. You can automatically tell if sine and cosine is going to be positive or negative by knowing your quadrants and knowing if x and y are positive or negative in it. Okay. So do we stop at 360 degrees? And the answer is no. We can actually go in circles as many times as we want. So let me go ahead and show you guys this. Okay, so I found this app online, and the idea is you can see the angle, right? So as we approach 90 to 180 to 270 and then to 360, well, what happens after that? Well, it continues. And on my second circle, we're at 270 degrees. 360 plus 360 is 270. Now, this is what we call, leads us to what we're going to call coterminal angles. Now, if you look at the second set here, if I spin them around, right? What we're going to look at here is that these angles repeat over and over and over. And coterminal angles are the angles that stop at exactly the same spot. So if I look here, let's go back, make it a little easier. So I'm going to take A, I'm going to go to 380 degrees. Okay, 380 degrees. Let's make it a little larger. Let's do 390. What would this angle look like in my first rotation? It would look like 30 degrees. And angle ABC, ABC, and DBC are coterminal. So let's talk about what coterminal means. Coterminal means they stop at the same spot. Even though they are not on the same level, they have the same angle. So 390 degrees is coterminal. It's going to give me the same angle as 30 degrees. So if you spin 30 degrees and your friend spins around like crazy 390 degrees, you guys are still going to be facing the same direction. And it's this fancy word that helps you realize that angles, even though some may be larger than others, will still have the same sine and cosine. They still end up in the same place. Radians talk nothing about how far you've walked. It's all about how much you've turned. So if you do a 360 and your friend does a 720, you guys are still facing the same direction. So let's go back. So when we talk about coterminal angles, which is my next word, coterminal, the idea is they have the same final angle. So whether in my example, I go 390 degrees, 390 degrees, or I just turn 30 degrees, they both have the same coterminal angle. They're coterminal with each other. And I mean, if we were in class, I would ask you guys to take out calculators now. But if you find the sine of 30 degrees or the sine of 390 degrees, you would still end up with the same answer, 1/2 for both. So I'm going to ask you, find me two coterminal angles for angle 60. So if I give you the angle 60 degrees, what else could you tell me would still be 60 degrees? Well, if you take 60 degrees and you add one full circle to it, this gives me 420. So 420 would be 360 plus another 60. This would be 420. And this is what we would say 60 degrees and 420 are coterminal angles. What if I want to go the other way, going backwards? Sure. If I go 60 degrees minus 360, spinning in a clockwise direction, this will give you negative 300 degrees. Let's go ahead and try that. So here's 60 degrees. And if we spin in a negative direction, see negative, negative 180, negative 270. Now I want to show you something kind of cool here. If I go forward, this is 60 degrees. If I go backwards, isn't this 30 degrees? So 270 plus 30 is the negative 300 that we wanted. All right, so negative and negative there. Let's make it a little cleaner. Plus negative 30, going the other way. Okay. So whether we look at 60 degrees, 420, or negative 300, these are all the same angle. Our final angle would be exactly the same. It might look like here that we're on different levels, but no, this is just to illustrate the multiple turnings that we're doing, the multiple times we're rotating. Radians and degrees talk nothing about the distance away. It's all about just how much we've turned. Okay, how much we've turned. Okay, so my follow-up question, let me ask you, are these two angles coterminal with each other? Let's do, is 480 degrees coterminal with 120 degrees? My first question is, hey, 480. Is 480 even in on my first circle? Is 480 my first circle? No, it's over. My first circle stops at 360. So what is 480? 480 is a little bit over. That's simplified for us. Let's take 480, and that's minus my first circle from it. We're left with 120. Hey, that's the same angle here. So if we draw it out, if I go 480 degrees, this first circle would be 360. If I keep going, we're at 360 plus 90 is 450. Just a little bit more, 30 more degrees. We are at 480 degrees. Well, what does 120 look like? 120 is 90 degrees plus 30 degrees. It's 90 degrees plus a little bit of 30. Yep, we're at the same angle. So we can go either forward or backwards. Both ways work for us. Now, I want to try adding to this just a little bit. What if I wanted to go the wrong way? What if I started at 0 and I wanted to go backwards? What angle do you think it would be that would stop exactly as 480 as well as 120? Let's start counting. This will be negative 90. This will be negative 180. And then we need, what type of angle here? Well, if this was 30, this would have to be
negative
60.
60.
So negative 60, thank you. So another 60 degrees. So we're at negative 240. Turns out negative 240 is also a coterminal with 480 as well as 120 degrees. And just to show that, if I say negative 240 plus 360, this gives us our 120. And if I say 120 plus 360, that gives us our 480. Totally related. And one thing we want to know, the idea of coterminal, it's going to relate later as we do sine and cosine. We'll have things that are related that way. And if we know one angle, we know them all. Okay, one angle to rule them all. Okay, the next one, this one is one of the trickiest ones, one of the hardest ideas. And this idea is the idea of reference angle. Reference angle. Now, when we're looking at the idea of reference angle, it's almost, you can say, it's like what you would refer to, what you would compare to, right? Your reference. What's your point of reference? And when it comes to reference angle here, it's this idea of given any angle on a circle, what angle would it be back to the x-axis? So the reference, my frame of reference is always the x-axis. So if I give you that's a 30-degree angle, well, isn't the reference just 30 degrees? Isn't it the same thing? But if I give you a 150-degree angle over here, what is the angle that brings you back to the x-axis? Or you could say always brings you back to horizontal. This is going to be 180, so the difference would be 30 degrees. Sorry. Crazy kids. Gosh, never mind. Okay. So what we're saying here is if I ask you what is the reference angle of 30 degrees, you would say it's 30 degrees. What's the reference angle of 150 degrees? That is also still 30 degrees. Reference angles will also always be positive for us. And they're always written between an angle between 0 and 90 degrees because they're all acute angles. Let's give you guys another one. What if I take the angle 210 degrees? 210, isn't that a little bit over 180? Well, how much over? It's going to be over by
30
degrees. Thank you. 30 degrees. So that's my reference. So the reference angle, oops. The reference angle of 210 degrees is going to be 30 degrees. Now we're dealing with easy numbers. Let me do one more just to show you guys in quadrant 4. I pick angle in quadrant 4, and that angle is going to be 330 degrees. How much more do I need to get back to 360, right? Because I want to get back to the floor. Well, that's also 30 degrees. So the reference angle for 330 is 30 degrees. Now, let's make this a little more convoluted. Let's make this a tougher angle. Here is what the reference will never, ever, ever, ever be. it will never be the angle that brings you up to vertical. It will never be this angle. It will never be this angle. We will never talk about this angle. Okay? Those don't count for us. Reference angle is always going back to horizontal, always going back to the floor. You can almost think of it as the angle lifts you up. How much are you going to drop to the floor? You're hanging up here. How much is that fall going to hurt? If you're buried 6 feet under, how much are you going to have to dig yourself back up? You're swimming in a pool. You're about to drown. How much did you swim back up to get some air? Always back to horizontal. Now, I'm going to throw a wrench in this. What would the reference angle of 435 degrees be? Seems a little bit weird. That's draw it out. That's figure out where it's at. Some of you guys might know it already, but let's just walk around the circle. 435 degrees would be one full circle. That is 360 already. 435 minus 360. That leaves us 75 degrees left.
Right.
Is 75 degrees enough to go vertical, or am I going to be a little bit short?
You're going to be a little bit short.
Thank you. I'll be a little bit short. It turns out I'm going to be right here. 435
Wow, you're
is
right,
this angle here. We just called
that
it.
one.
It's going to be 75 degrees.
Right.
That's my reference. Because we're always coming back down to the horizontal. What if I pick a angle that's a little bigger than this? Let me see. Let's do 550. 550 degrees, kind of large. What's your reference angle for 550? So let me write some easy ones. This is 360. This is 450. This is 540. So what quadrant do you think I'm going to be stuck on for angle 550? Quadrant 1 or quadrant 2? 3 or 4?
3.
3. I'm hearing quadrant 3. Because aren't we a little bit over 540?
Yeah.
All right. Let me draw that. 540. Oops. 550. So how much over are we to crawl back up to hole?
10.
10. I'm hearing 10. And it's not going to be negative 10. It's going to be positive 10. A reference angle is just the angle I need to go back to horizontal. And in this case, our reference angle is going to be 10 degrees. The reference angle for 435 is going to be 75 degrees. And let's just do one more. The reference angle here for, let's do negative 123 degrees. Then write out some markings in the negative direction. This is 0, negative 90, negative 180. We're going this way, okay? Negative angles. So negative 120 is for sure stuck between 90 and 180. So we're going to be stuck in quadrants 1, 2, 3, 4. I'm hearing someone telling me 4. Oh, 3. I'm sorry, 3. So we're going to be someplace around here. 123. Now, again, we are not trying to get over here. We never use that vertical angle. It's always crawling ourselves, try to get back for some air.
Right.
So how do we get up? You can use addition. How much more do we have to add to 123 to get to 180? You could subtract them. Either method you want to use. I see it's going to be 57 degrees. So my reference is 57 degrees. Now, what if we do this with radians? Like, what if we are asked to do this with radians? And it could be a thing. And on iExcel, this is the easy idea of doing it with degrees. But what happens when they ask us to throw in some radians into it? And remember, radians are counting by pies. So let me give you a hint. Let's go ahead and talk about this. What would the reference angle be for if theta was, and let's write this in radians, was, let's see, let's use 3 pi over 4. Okay, 3 pi over 4 in radians. Okay. Now, in your head, let me ask you, is 3 over 4 bigger or less than half of pi? Okay, think of it in your head.
Big.
Is
No.
3 over 4, 75 cents, bigger or less than half of pi? 3 out of 4. It's like 75%, right? 75 cents?
So it's big.
So it's bigger. So the reason why I'm bringing this up is because I want you guys to be able to quickly figure out in what quadrant are we in. We're not bigger than a full pi. That would be 4 over 4. We're definitely bigger than half of 4, which is 2. So we're going to be stuck someplace in the middle here. 3 pi over 4. Now, here is the super easy part about radians. It seems hard. It really does. Please don't freak out. Do you see how I wrote it with a common denominator? How can I get from 3 to 4? Don't I just need one more?
1.
And the reference is 1 pi over 4. Let me make this a little dumber, okay? Theta is 9 pi over 8. What quadrant do you guys think this will be in? So I'm going to set up a poll really quick. The poll is going to ask you guys which quadrant this is going to be in. Give me one sec. So think of it right now. What quadrant is this going to be in? 1, 2, 3, or 4?
A. That's 3.
One second.
Quadrant 4.
Oh, shh. Quiet. Poll.
Oh.
Okay, launching poll. Go ahead and tell me what quadrant you think this is going to be in.
Did he really just do a poll?
I just did a poll. Legit. Let's end the poll. See where we're at. Share results. So a lot of you guys think this is in quadrant 1, 2, 3, or 4. Most people think it's in quadrant 4. Let's talk about it. So remember, if we look at radians, this is 0. And then also, to go around the circle, this is also considered 2 pi. This is pi over here. How much is 9 pi over 8? Do you think that's a little bit over a full pi or really close to 2 pi? A little bit over 1 pi or really close to 2 pi? And it's a little bit over 1 pi, isn't it? Turns out it's in quadrant 3. Because it's literally 1 over 8 over 8. So you guys want to be able to quickly change radians into fractions. A 1 full pi is just 8 over 8. It's just itself or it's over itself. Would you guys agree that 9 over 8 is just a little bit over? Okay. If I'm over here, 2 pi is really 16 pi over 8. What's the halfway point between 16 and 8? That's 12 pi over 8, which reduces to 3 pi over 2. And that's where this is. This is 270 degrees. Okay, so pay attention. I'm gonna make this easier for you. What's my reference? So if this is 8 over 8, and we went up to 9 over 8, it's only pi over 8 away. Okay, because our idea is we're trying to get back to the horizontal. So what is that difference? What would that angle be? That's the difference.
Pi over 8, right?
Pi over 8, that's right. Okay, let's do another one. This one's going to be a little with a negative sign. Theta is negative 13 pi over 12. Okay, negative 13 pi over 12. These are slightly uncommon, right? Pi over 12, we won't see it that much, if much at all. But it still gives us an idea of where would we be. Going in the negative direction, 0. Going left would be negative pi over 2, just to write that. Now, I want you guys to change this all to divide by 12, fractions of 12. So this is negative pi, this would be negative 12 over 12. Is it cool for you guys, for me to say this? Right? What's half of 12? This would be negative 6 pi over 12. Keep going. If this is negative 3 pi over 2, okay, multiplying that by 12, this would be 18 pi over 12, negative. So if I write it in this other way, you can definitely see where this falls. Now, quickly now, I want to do the poll again. Please tell me what quadrant would negative 3 pi over 12 fall into? Remember, we're stuck between negative 12, a little more than negative 12, a little less than 18. Okay, 30 seconds for the poll. That's good. Show the results. A majority of you guys chose to say, hey, it's quadrant 2. And that's actually correct. It is quadrant 2. If you look at where we fall, here at negative 13, counting this way, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13. That's our negative 13 pi over 12. We would have to be bigger than 18 to be over here, because our goal is, if you want to, is negative 24 over 12. That would take us to 2 pi. So here's a hint. Remember, double means we're at 2 pi. If we're dividing the fraction over the fraction, we're at 1 pi. So what's my reference? To get from 12 to 13, that's only 1 pi, pi over 12. Okay, let's pause here. Okay, so for our next problem, we're looking at our new problem. Give me a moment, guys. We do 15 pi over 6. We walked around. We first started off with 0. Then we went to 6 pi over 6. Then we went back to 2 pi, which is 6 plus 6 is now 12. Add another 6 becomes 18. Now, are we bigger? Is 15 bigger than 18? No.
No.
Right? It's bigger than 12, bigger than 18. Let's see, what's the midpoint between 12 and 18? That's going to be
The 3.
15
Oh,
over 6.
yep. Yeah,
Cool.
you're right.
So when we're at 15 over 6, do we have a reference angle? Answer is no. We don't have a reference angle here. Okay, so this was a good one, but we have no reference angle because we're not going to go in either direction. So the answer for this one is there actually is no reference angle.
This is in the middle, right?
Right, because it's right between those two quadrants. So there's going to be no reference here. And they won't ever ask you this type of question. I just wanted to point it out in case you had that type of question. So there are times when it will be no reference. Now let's use this example here, and let's just find the reference angle as we swing left and swing right. Okay, so I'm going to ask you, if I give you 16 pi over 6 and 14 pi over 6, what would the reference angle be for these two? Okay, going this way, that's 14, and going this way is 16. So what would we get by coming back down? Don't overthink it, please. Don't overthink it. To get from 12 to 13, no, sorry, 12 to 14,
Pi 6.
Well, how many? 14 and 2 would be
Pi
14 minus 2 is
minus 2 is 2.
Pi over 3.
I mean,
So
2
12.
pi over 6,
Yeah.
which can be reduced to pi over 3. Okay, so that's the difference. If I'm at 14, and if I'm 14 here, I'm going to come back to 12. The difference is going to be 2 pi over 6, which can be reduced by 3. This is by 2. It's 2 pi over 3. Let's look on the other side.
Oh, I get it now.
Cool? Good.
Yeah.
16 to 18. What do you think the difference there is? If I got to climb back down, it's going to be 2 pi over 6 again, because I need 2 more to come back down, because we always want to get back to the floor. This reduces to also pi over 6. No, sorry, pi over 3. I'm sorry. Pi over 3. Okay. So I feel like drawing out reference angle does help a little bit till you guys get really good at it. But if they come out with the unfamiliar reference angles, definitely drawing them out to figure out where on the unit circle you are, which quadrant you're in, I think is helpful. And then we can always draw it back down to the horizontal.